4 billion years ago, Earth was not the world we know today. There were no mountains, no forests, no breath of wind across golden plains. There was only ocean, a vast, endless, primordial ocean stretching to every horizon beneath a sky of deep amber and toxic haze. The young Earth churned with violence. Beneath the waves, the crust was thin and restless. Magma surged upward from the mantle in relentless plumes, cracking the seafloor open and pouring heat into the cold, dark water above. This was the Archean Eon, a chapter of Earth's story that began roughly 4 billion years ago and lasted for 1.5 billion years. An age almost impossible to imagine. An age when the rules of our planet were still being written. Deep beneath the ocean's surface, something extraordinary was happening. Where tectonic forces pushed molten rock upward with enough force, volcanic islands began to form. Cones of black basalt breaking through the waves for the first time. Jagged, raw, steaming. But these islands were not continents, not yet. The real story of how continents were born is a story of chemistry, pressure, and deep geological time. As volcanic material accumulated on the seafloor, it was dragged downward into subduction zones, where one plate slid beneath another. Under enormous heat and pressure, this rock melted and transformed. It changed its mineral composition. It became less dense. It became lighter, and lighter rock rises. This transformed material, now called felsic rock, pushed upward through the crust, cooling slowly into vast bodies of granite. Unlike the dense basalt of the ocean floor, granite could not be pulled back down into the mantle. It was too light, too buoyant. It floated. These granite masses became the seeds of the first cratons, the ancient, stable cores of continents that geologists still map today, buried deep beneath billions of years of younger rock. The Pilbara Craton in Western Australia, the Kapval Craton in Southern Africa, the Superior Province in North America. These are not just rocks, they are memory. The oldest surviving fragments of the Archean world, some dated to 3.5 billion years, some older still. In the Archean Ocean, these cratons rose slowly. Millimeter by millimeter across millions of years, their granite surfaces were pushed above the waterline. The first true land on Earth was not dramatic. There were no cliffs crowned with vegetation, no rivers carving valleys, just flat, dark volcanic rock, battered by rain, cracked by heat, and surrounded on all sides by ocean. The Archean sky above this land was nothing like our own. There was no protective ozone layer. The sun's ultraviolet radiation hammered the surface without mercy. The atmosphere was thick with methane, ammonia, nitrogen, and carbon dioxide. There was almost no free oxygen, not yet, but life had already begun. In the shallow, warm seas surrounding these first cratons, microbial life was establishing itself. Simple, single-celled, invisible to any eye that would not exist for billions of years, but alive, metabolizing, reproducing, slowly reshaping the chemistry of the ocean and the air. The oldest known fossils on Earth are from this era. Stromatolites, layered structures built by microbial mats in shallow tidal zones, have been found in the Pilbara of Western Australia, dated to 3.5 billion years ago. These were not animals, not plants, but they were the beginning of everything. Meanwhile, the Archean crust continued to evolve. The early Earth was hotter than today. The mantle convected more vigorously. Tectonic activity was faster and more intense. New volcanic arcs formed, collided, and merged with growing cratons. With each collision, the continental cores grew larger. Mountain belts rose and were eroded flat. Sediment poured off the young land into the surrounding seas, building up thick sequences of rock that would later tell the story of this age to future geologists. The Archean was not static. It was restless, creative, and catastrophic by turns. Meteorite impacts still scarred the surface regularly. The late heavy bombardment, a period of intense cosmic collisions, had only recently ended, and scars from that era were still visible across the young crust. The oceans themselves were chemically alien, rich in iron, warmer than today's seas, colored a deep reddish-green in places from dissolved minerals
the Earth's
and
atmosphere was
microbial
a
blooms,
toxic mix.
where hot hydrothermal vents pumped mineral-rich water into the cold, deep ocean. Complex chemical gradients formed, providing energy for early microbial ecosystems. Life was not just surviving the Archean, life was using it, bending it. Slowly, over hundreds of millions of years, microbial activity was beginning to shift the chemistry of the atmosphere. Small but measurable pulses of oxygen were entering the air, released as a metabolic byproduct of early photosynthesizing microbes. This was the very beginning of a transformation that would eventually make our planet breathable. But that revolution, the Great Oxidation Event, was still hundreds of millions of years in the future. For now, the Archean world remained ancient,
Archean
alien,
greenstone belt,
and magnificent
preserved
in its
record
own
of
brutal
ancient
way.
volcanic ocean
As the
crust
eon drew
trapped
toward its
between
close,
growing cratons.
roughly 2.5 billion years ago, the continents were still small by modern standards. No single landmass dominated. The planet was a mosaic of young cratons, volcanic arcs, ocean ridges, and shallow seas. But the architecture of the modern world was already being laid. The process that would eventually build Pangaea and then break it apart and build our modern continents was already underway. The Archean Eon gave Earth its foundations, not just the rock beneath our feet, but the biological legacy that runs through every living thing on this planet. Every cell in your body carries molecular machinery that traces its ancestry to those first microbes, surviving in hot Archean seas, billions of years before the first breath of clean air, billions of years before the first animal eye opened on a world still learning to exist. The Archean was not the beginning of the universe, but it was the beginning of us.